Let's talk about the Triangle Sum Theorem, which teaches us one of the most essential pieces of information about triangles, and that's that the sum of their interior angles is always equal to 180 degrees. Interior angles, of course, are the angles inside of a triangle. So in the diagram you see on the screen, angle 1, angle 2, and angle 3 are interior angles because they're inside of the shape. An exterior angle is formed by extending one of the sides outside of the shape, such as angle 4. We'll talk more about exterior angles in the next video, but for now let's focus on interior angles. If you add the measures of the three interior angles of a triangle, it will always be equal to 180 degrees. We can use this theorem to help us solve for missing angle measures in a triangle. As long as you know two of the three angles, you can figure out the third. So for example, I have the measure of angle A is 81, and the measure of angle B is 68, so what's the measure of angle C? I could write this equation to solve. 81 plus 68 plus the measure of angle C is equal to 180 degrees. And if I subtract 81 and 68 from both sides, I get an answer of 31 degrees. You can also apply this theorem to a more algebraic context like this one. We're going to have to set up an equation and solve for x, and then plug x back in to figure out the angle measures. Let's take a look. I'm going to add all three of those algebraic expressions together, 4x plus 7, plus 6x plus 2, plus 9x, and set that equal to 180 degrees. Combine like terms, subtract 9 from both sides, and divide by 19, and we find out that x equals 9. But our instructions asked us to calculate the measures of each angle, which means I need to take 9 and plug it into each of the x's that I see in the diagram. So I'll do 4 times 9 plus 7, and 6 times 9 plus 2, and 9 times 9. And I would get each of these answers. The measure of angle D is 43 degrees, the measure of angle E is 56 degrees, and the measure of angle F is 81 degrees. You should always double check your answer on a question like this by adding those three measurements together and making sure that it actually equals 180. Because if it equals something else, then that means that you solved incorrectly for x, and you would need to go back and fix your work. But since 43 plus 56 plus 81 is equal to 180 degrees, I know I've done this correctly. You don't even have to have a diagram in order to use this theorem. As long as you know the three angle measurements of a triangle, represented in this case by algebraic expressions, you can add them together and set it equal to 180. X plus 2x plus 3x is 6x, so that means that x for this problem must be equal to 30. So the measure of angle 1 would be 30 degrees, the measure of angle 2 is double that, so 60, and the measure of angle 3 is triple that, so 90. So that actually tells us that that's a right triangle. This triangle, represented by these three angle measurements, has one angle that's equal to 90, so this would be a right triangle. I want you to pause the video and try this one on your own. Calculate the measures of angle 1, angle 2, and angle 3, given the algebraic expressions you see on the screen. Pause the video and try it now. Let's see how you did. The equation I would write is 5x minus 1 plus 8x minus 5 plus 23x plus 42 is equal to 180. I just added all three of those expressions together and set it equal to 180. And now I'll combine like terms, subtract 36 and divide by 36, and I get an answer of x equals 4. To get each of my angle measurements, my actual answers, I'll plug 4 in and get answers of 19, because that's 5 times 4 minus 1, and 27, because that's 8 times 4 minus 5, and 134. So that's 23 times 4 plus 42. Looks like this one is just an obtuse triangle. No 90-degree angles this time. We just have one angle that's bigger than 90, so this triangle would be obtuse. Speaking of right triangles, though, we can make a more specific version of the triangle sum theorem just for right triangles. If you know you have a triangle that is right, then you know it has one angle that's equal to 90 degrees. And according to the triangle sum theorem, if you add up all three angles, it must be equal to 180. But if you know that one of the angles is 90, you could just subtract 90 from both sides and say that the sum of the other two angles, the acute angles, would be equal to 90. So this is really the exact same thing as the triangle sum theorem, it's just a shortcut. You've already subtracted 90 from both sides, you're just adding the two acute angles together and setting that equal to the remaining 90 degrees. Let's take a look at an example. Here we have a right triangle. Since angle H is marked as a right angle, that must mean the triangle GHI is a right triangle. Now for all triangles, I can add up all three of their angles and set it equal to 180, so I could say that 61 plus 90 plus the measure of angle G is equal to 180. And then I could subtract 90 from both sides, get rid of that right angle from both sides, and I would just have that 61 plus the measure of angle G is equal to 90. So it's the same thing as the triangle sum theorem, you just cut out that first step of having the right angle being added with the other two and the whole thing being equal to 180. These two angles, the acute angles of a right triangle, have to add up to 90 degrees, which in this case means that the measure of angle G, if I subtract 61 from both sides, must be 29 degrees. And of course you can apply this to algebraic problems as well. I would just add these two algebraic expressions together and set it equal to 90. Alternatively, if you don't want to use the corollary to the triangle sum theorem, you don't have to. If you'd rather write that 20x minus 3 plus 11x plus 90 is equal to 180, you're welcome to do so. You'll get the same thing in the end though, because really you're just subtracting 90 from both sides to get to this point. The corollary to the triangle sum theorem is just a shortcut. So let's combine like terms and add 3 and divide by 31, so x must be equal to 3. Plugging 3 in, I get answers of 57 and 33, and of course the measure of angle L is 90 degrees. Let's try this as a word problem. I'm going to describe the angles of a triangle to you, and we're going to write an equation to represent it. The measure of one acute angle of a right triangle is 2 times the measure of the other acute angle. Well, first thing I need is a diagram. I'm told that it's a right triangle, so I'm going to draw myself a right triangle. And we've actually done problems like this before, and I told you that every time I give you a problem like this, that it says that something is this many more than that many less than whatever, call one of the angles x. Just plain old x. Just call it x. Just pick an angle and call it x. And then the other angle you call in terms of whatever it describes. In this case it says just 2 times. It's 2 times the measure of the other angle. The measure of the other angle is x, so it's 2 times x. So 2x. Well, now that I know both of the measures of the acute angles of this triangle, I can add them together and set it equal to 90 according to the corollary to the triangle sum theorem, which means 3x equals 90, so x equals 30. In other words, one of the angles must measure 30, and the other angle would measure 60. And of course the third angle is a right angle, so it measures 90 degrees. Let's try one that's just slightly more challenging. The measure of one of the acute angles of a right triangle is equal to 5 more than 4 times the measure of the other angle. Well, draw yourself a diagram. Go ahead and draw a right triangle, because that's what it says we're working with. And since this is the kind of problem where it says that something is this many more times and that many less than the whatever, call one of the angles x. Just plain old x, call one of the angles x. Just x. And then call the other angle however it describes, in terms of x. In this case it says it's 5 more and 4 times the measure of the other acute angle. The measure of the other acute angle is x, so it's 5 more than 4 times x. That would be represented by 4x plus 5. 4 times x, that's 4 times the measure of the other acute angle, and 5 more, that's the plus 5. So the measure of angle 1 is x, the measure of angle 2 is 4x plus 5. Since those are the acute angles of a right triangle, I can add them together and set it equal to 90 and solve for x. So since x is 17, that means the measure of angle 1 is 17. The measure of angle 2 is 4 times 17 plus 5, which would give me 73. And of course the measure of the third angle would be 90 degrees. So let's see if we can use the triangle sum theorem and its corollary, and maybe even some stuff that we learned earlier this year, to solve for each of these angle measures. For example, what's the measure of angle P? Well, I see that angle P is one of the angles in a right triangle. It's one of the acute angles. And according to the corollary to the triangle sum theorem, I know I can add the 2 acute angle measurements together and set it equal to 90 degrees. So that means that the measure of angle P would be 58 degrees by the corollary to the triangle sum theorem. What about the measure of angle SRT? Well, it just forms a vertical angle with angle QRP. So the measure of angle SRT, or TRS, is 32 degrees by the vertical angles congruence theorem. It's really important on a problem like this, like a multi-part problem, that you label your diagram with each of the answers that you find. Because if I hadn't just labeled my diagram with 32 degrees for the measure of angle TRS, it would have been a lot harder to figure out the measure of angle S. But since I do have 32 on my diagram, I see that I have 2 of the 3 angles of triangle RST. Now, triangle RST is not a special kind of triangle. It's not a right triangle like triangle PQR was. It's just a normal everyday triangle. But we know, according to the Triangle Sum Theorem, that you can add all 3 of the interior angles together and set it equal to 180 degrees. So I can write this equation and subtract 32 and 81 from both sides to figure out that the measure of angle S, or the measure of angle RST if you want to use all 3 letters, is 67 degrees. Let's try another one. Again, we're going to kind of combine the things we're learning today with the Triangle Sum Theorem and the corollary to the Triangle Sum Theorem with some other angle relationships that we learned earlier this year. The first thing I notice is that in triangle JKL, I know 2 of the 3 angles inside of that triangle. And the Triangle Sum Theorem tells me I can add up all 3 of those angles, so 57 plus 92 plus the measure of angle JLK, and set that equal to 180 degrees, which means the measure of angle JLK would have to be 31 degrees by the Triangle Sum Theorem. But what if I wanted to figure out the measure of angle MLN, this guy right here? Well, we could actually use linear pairs, or supplementary angles. 31 and 113, this whole angle, angle JLM, would be equal to 144 degrees. And I know that 144 degrees plus this missing angle measurement of angle MLN, that would have to be equal to 180 degrees. So the measure of angle MLN would be equal to 36 by the linear pair postulate. And what about angle M? Well, there's kind of 2 ways to do it. First, I notice that angle M is one of the 2 acute angles in a right triangle, so I could add 36 and angle M and set it equal to 90. But maybe you didn't notice that it was a right triangle. You could also just write 36 plus 90 plus the measure of angle M and set that equal to 180. Either way, you would end up with an answer of 54 degrees for the measure of angle M, or LMN if you want to name it with all 3 letters. The work that I showed would be the corollary to the Triangle Sum Theorem, because I just added the 2 acute angle measurements and set it equal to 90. If you had done 36 plus the measure of angle M plus 90 equals 180, then your answer for the justification would be the Triangle Sum Theorem. And that's all you need to know about calculating the interior angle measurements of triangles using the Triangle Sum Theorem and the corollary to the Triangle Sum Theorem. In our next video, we're going to discuss how to calculate exterior angle measurements for triangles.